Okay, so here I'm going to show you how to plot, especially with the precipitation data, and later we will do the same thing with the temperature data. So this is my folder where I'm going to work. So here I am opening my page. So okay, so before that you just need to assure that Jupyter Notebook has been installed in your cell. So currently it is in Conda environment. My Jupyter lab is installed in different environment, so I'm going to that environment. Hopefully you don't have to change your environment because you have already that Jupyter Notebook probably in your current environment. So this step you don't have to perform. So after that, now from here actually you have to perform the step. So currently my Jupyter Notebook, this content is not working, so I'm working with Jupyter Lab. However, the things are same, you can see. Okay, so here I'm opening my new notebook. Select. Okay, so before working before starting your work, just check the path of the folder, that where are you and what are the files that is available. And okay, so this 2netcd file should be there. Okay, and that is the first you have to make sure. Now you have to import all the library that we are going to use. Xarray, you can make it short. Xarray import numpy as np, import matplotlib dot py plot as plot, import from npl toolkits dot base map, import base map. Okay, if anything, like if you observing that any error occurred which says that the module is not present, you have to install. So let's for assumption that if you type from toolkits.basemap import basemap, it is not working. So it is showing that basemap module is not available. So what you have to do in this particular cell, you have to type installed basemap. Okay, if your internet is okay, then it will install in your system. Apart from that, you can also, we will see how to use Cartopy later. So currently I'm showing the basemap. Okay, so first I will open the file. So here I'm working with the precipitation file. So here first I will open the data file. You can give any name, it doesn't matter. Extract.open data set. Now you can tab, if you put tab you will get the file name here. Now you can add one more, so you can see this is your file and this should be within quotation. Okay, so now if we do the print data, you will get the detail. So you can see the data is there are some this is called bounding. It's actually you can ignore easily. So total time step, it is available 550 to 550. This is the lat long total range. And if you want to find out the name of the variable, this is the name of the variable that we are going to extract. So first what you have to do, based on this information, we can easily extract this variable. So here I'm extracting the precipitation variable. Okay, make it short, that P equals to data, within the third bracket you can just type precip. Okay, Now remember one thing, if you type any wrong variable, let's say pre-RA, you can see it will generate an error. It will show that no variable named Precipitate. So that means you need to extract the correct variable name, then only you will extract. Now next, you can also print the information, metadata information for Precip. So this is the metadata information, like this is the unit millimeter per day. Okay, this is the valid range, that is 0 to 100, and it is surface data, it is mean. Okay, so this is the basic metadata information that you need to extract. Okay, now remember this file is in monthly, so you don't need to do much things, since for annual Climatology it is easy to convert into annual. So for that, what you have to do, if you want to create annual mean, a mean, I'm giving such kind of mean so that I can isolate everything. So precipitation mean. So now this variable I have extracted. Now here I am doing the average mean for time dimension. So I am giving this one. So now here we have done the average. So this you can check out. You can check out the detail. You can check. It's always suggest. It always advise that after every stage, the variable that you have generated, you should print the detail. Okay. So you can see now. Oh God. Oh sorry. I'm printing wrong. So I need to give a mean. So you can see there is no time dimension. So basically, because since we have averaged toward the time dimension has been vanished. Only now the perimeter becomes 2-dimensional. Now we have to see that how to plot it. Okay. Now to plot. First, there are very simple way how to plot. Very simple way we can plot, but I'm not going into that. I'm directly using the base map. But for base map, you have to extract the lat long information from the variable. You have to extract the values. Okay, so you have extracted the values. Now after extracting, just check string object. I don't have, sorry, incomplete. Okay, I did it. Oh. So now we have extracted the values. Now here I am creating a plot area. So to create a plot area, first we will add a figure space and axis space using matplotlib. Since if you see, PLT is basically a short name of matplotlib. So basically using matplotlib we are extracting. Here you need to give the subplots, then only it will extract the figure and axis. Otherwise it will only extract the one item and it will show you some error. Figure size equals to the first bracket. You can keep the size. It can be modifiable. We will see after modifying. We will see how to modify it. Okay. Now here I am adding a base map. Now base map, we are basically creating a base map. Now within this there are different arguments, that is projections. There are different projection that is available. Currently I am using cylindrical. You can check the list in website. If you go to the website, sorry, I'm on the website, and if you click on it, base map Python. If you check this thing, you will get the detail more. So you can see base map tutorial. So here you will get different projections. Let me just find out the key argument. Projection. So there are different kind of projections out there. Cylindrical projection gives you this kind of projection. Okay, if you give AEQED, okay, so it gives normally this is used for polar, when we focusing on the polar region. Okay, then there are some other polar region when we are focusing on particular area. So here you can see no such projection has been used. Because it is particularly specific to the some map type. Okay. So that is the satellite projections. When you are taking some cross-section using satellite data, that is another projection. So there are different kind of projection you can check in the base map tutorial page. I think some more projections will be there. You can list it and check it out, but currently I am using the cylindrical one. Now the next argument will be the resolution. Always keep it in large resolution. Now you have to put the boundary. So lower left corner lat, it should be the minimum value of lat, but it should be NP. Okay, NP minimum, that is the lat. Okay, now next it will be sync. Lower left, you should not give any gap here. So lower left corner lawn NP dot max lats. Then this is the lower left. Now you have to give the upper right corner lawn. Sorry, I think you should give first upper right. Yeah, upper right. Sorry, I'm just making some mistake because first you have to give the lat value. So lower left is the minimum, upper right is the maximum value of light. Similarly, lower left longitude, it is the minimum value of long. Then upper right corner lawn, upper right corner lawn, it should be upper right corner NP dot max. Okay, so you can get it. So this is the long. So this is how you can create a base map field. Base map field. Now you have to add the attributes of base map. So some attributes that actually creates the boundaries. Draw coastline. Okay, now here you have to mention, you can see the attributes. Draw coastlines are there, draw countries, draw state boundaries. So this is the different kind of attributes are there. Since here I am plotting the global map, we are just focusing on the coastline. You can add something more. Now here you have to see how to add the axis. So there are two attributes. One is the draw parallel, which actually adds the latitude. So it ranges from -90 to 90. Okay, here it should be NP numpy area you have to put it, otherwise it will not add into the map. So you have to use NP range. Okay, NP range you can use -90 to 90, then you can only keep 10 step. Now here again this is parallel, that is for latitude. So next argument for this attribute will be the levels. That it basically defines where you are going to put the axis. There are 4 sides. Currently I am putting 0 all over. We have to put 1 in any one place, then we can see that we will modify it and we will show you. And then we have a font size information that we have to keep, that is 10. Now similarly we will add the details for longitudes, that is draw meridians. Here again np dot arrange, okay, minus 180 to 180 is 10. Again labels equals to 40, keeping it. I will modify later to make you understand that where you should, how to use this actually. So font size is 10. So this is the base map attributes I am adding. Now next the thing we need to add the axis detail, but before that we need to create a mesh grid, that is long and lat. Remember in the x-axis in 2D diagram it should be long in the x-axis and it should be lat in the y-axis. So np mesh grids, so np dot, okay, np dot mesh grid. Here I am putting the extracted information earlier, that is longs and lat, and then I will add this to the base map. So axis x and y, right? So x-axis will be the long lat, okay. So m is the base map object, long lat. Now at the end we will plot it. So our plotting object, we have to give a proper name to our plotting object, C, or you can give it anything. Now M, again base map. Now contour F, it basically plot a field contour. You can check the plot types, there are different plot types will be available, X, Y. Now here what variable we are going to plot, it is a precipitation mean. So here I am typing precipitation mean, okay. So PR mean. Now then we have to add a color. We will see different colors. Currently I am just giving one color, viridis, okay. Stained both, okay, both. Now here I am adding some more attributes, some to modify. Now we are adding the color bars, okay. Now here I am adding color bars. It is very important because when you are plotting a spatial plot, especially with the shaded contour, it is important to give a color bar so that you can define the area with proper grading, okay. So m dot color bar, now here for which, this is the first, this is the thing, the object, then you have to decide the location. You can keep it left, right, top, bottom, wherever you want. I am keeping the thing, and pad basically define the distance between the axis and the color bar area. Now here you can set the level. Here you can set the level, that is CB dot set level. So basically set level is the function of matplotlib, because if you see you need to identify the object, that each and every identifier is an object. So now here I am giving a title, precipitation, it should be in quotation, precipitation in millimeter per day. We have already checked the unit, so now we don't have too much to. Now here I am giving some particular title, plot dot title, then you can add, annual climatology of precipitation. Okay. This is the way you can do, and at the end you have to type this, otherwise it will not show. This plot show. Now if I type, okay, there are some error in here. Okay, I didn't put comma. Okay, fix size. So here it mentioned the plots. Okay. Oh, okay. So draw arrows. Draw meridians. I made some mistake actually. So okay, contour F. These are actually some spelling mistake I did. Contour. Okay, now okay. PR mean is not defined. Let me check. Okay, so here it's not PR mean. You need to give the variable PR mean. Okay. Now I got it. Okay. So here you can modify the color. You can check in the Google. CMap colors. So you can check what period is basically this one. If you want some other one, let's say GNBU. There are different sequence available. Okay, it depends on you that what type of plot you actually want. Let's say when you are using for animal, it's better to use 2 shade plots. There it is given one, and if you want, this is the one shading. So I am trying for some other one. There are for individual colors. So let me check which I can use. Okay, so I'm going to use precipitation for blues. You have to just, one thing you have to remember, you have to write the name of the color as it is. Okay, so I'm changing this. And let me check this. The color has been changed, you can see. Okay, this is how you can modify the color. And now see, there is no axis name. Now that thing we can just check. If I type 1, what you can see? You can see the axis. Now that is here. Now if I put 1 here, so it will add axis this sides also. So I don't need this much, right? So I just keep 1 here. Now I will put 1 here to check where the axis it will come. Oh, it's the above, but I need it below. Right? So what I will do, I will change it to 0 and I put 1 here. Okay, so now what I got, okay, still there is some overlapping, right? Because so one thing you can do, you can modify this thing. Okay, you can modify this. Let's say you can keep it 30. you can keep it 30, and then if you run it, you can see, oh, that's good, right? Okay, now this is the one way you can plot the annual climatology of precipitation, and you can see you have to keep. Similarly, you can plot the annual climatology of temperature. Okay. Now okay, so first you plot the annual climatology of precipitation and temperature from this to 5. So all of you download the data and plot the annual climatology for precipitation and temperature.